Yeah.
No.
Bro.
She played.
You can go.
What's up, guys? We're back at it. What's today? Tuesday, lesson 6.1, part 2.
No.
Wait, what the?
She missed the other
It's
day.
part 1 and 2.
Okay, part 1 and 2, my bad. Ka-chow!
It's very confusing. Everybody get this down?
Oh.
So we are, did I ask for that to be put away? Yeah, it needs to be put away. If I see it again, on the board, okay? All right, so we're gonna talk a lot about like naming things. Like, you know when back in the day when you were learning about shapes and you were learning about how to classify shapes by the rules that they follow. Like when you learned about quadrilaterals. That was a big word for you young people back then, right? Quadrilateral, you probably couldn't even say it. And you learned what a quadrilateral is. What's the rule that a quadrilateral has to follow?
Forgot.
Carmine, what's a quadrilateral?
Both sides parallel.
No.
Wait, at least one.
Oh my gosh, you guys are just using this as like a silly example of how to classify things that we already know how to classify.
No.
Are you dying too? I'm dying a little bit. Okay, we're dying inside. That's okay. What is it? Try again.
I'm saying like one side are parallel to each other.
No, I know it. I knew what you meant when you said the thing before. It's still not right. What's a quadrilateral?
Oh,
Yeah, it's a polygon with 4 sides.
I was thinking of it.
Very good. That's what a quadrilateral is. It only follows that one rule. It's got to be, well, 2 rules. It's got to be a polygon. It's got to have 4 sides. Okay? So, if I were to classify a rectangle, let's say, I could call it a quadrilateral, right? Because it does follow that rule. But I just called it a rectangle. So, why does it have another name? Why don't I just call it a quadrilateral? Yeah?
Because a quadrilateral is like kind of like a group of shapes. Because each shape with 4 sides is a quadrilateral.
Quadrilateral.
You know that
Yeah.
word.
Mhm.
Like a square, rectangle, rhombus,
Mhm.
diamond.
Right. But why do I call it a rectangle then? Why don't I just call it a quadrilateral?
Because the rectangle has a certain number of parallel things, like 2 parallel sides, like that and that.
It does, but then why don't I call a rectangle a parallelogram? Because a parallelogram is a quadrilateral with 2 pairs of parallel sides, yeah?
Because there's multiple, there's multiple like parallel, whatever the word is, and like quadrilateral, whatever. And then I'm having a stroke. Anyways, since there's so many of them, you gotta like,
Narrow it down.
yeah, you gotta
Narrow it down by what? What's so special about a rectangle that I can't just call a parallelogram?
Because it can also.
Oh, stop. Tell me about a rectangle. Why is it so special? Why do we have to have a special name for a
Because it can
rectangle?
also become a square.
No!
If it really tries hard enough, maybe one day.
Because 2 sides are longer than the other 2 sides.
With most rectangles, yeah, but technically a square is a rectangle. But that's not the rule that it follows. Also, that could be a parallelogram also. Yeah.
It's unique. The shape is unique.
Why is it unique?
Because
Nobody knows what rule a rectangle follows? Yeah?
Square plus B squared equals C
That's
squared.
a triangle.
Oh.
What's the difference between a parallelogram
Oh,
and
no,
a
parallel
rectangle?
and it's rectangle is not parallel. Wait.
All straight sides.
Oh my gosh, I need to be absent again. This is crazy. What's the difference between this parallelogram and the rectangle? What special rule does this rectangle follow?
The rule of rectangles.
oh my god.
It wasn't helpful. It wasted
It's
time.
because the sides are
You
slanted.
look like that.
The sides are slanted.
Okay, we don't, okay. We, yes,
Okay, so all sides are equal in the parallelogram.
No.
I know. You've tried like 30 times and you missed all 30 shots. Two sides are on an angle. Two sides are on an angle, and
on an angle, they all
Like-
have angles.
like, no.
But it's interesting that you're talking about the angles.
Oh! One of them has an 90-degree angle and the other one doesn't.
If I had candy, I'd
That's disgusting. That's actually so nice.
Your paper is like.
You're right. The rectangle follows the extra rule of having 4 right angles. But a rectangle is a parallelogram and it is a quadrilateral. We just classify it more specifically because it has more specific rules. And a square also is a rectangle, and it also is a parallelogram, and it also is a quadrilateral. It just follows the extra rule of being a rectangle that also happens to have equal sides, so we don't call it a rectangle anymore, we call it a square. So, with that being said, guys, that was supposed to be like a 30-second bridge into this lesson,
That was a 45 minutes.
assuming that you guys know something about shapes.
No, I forgot.
Oh my gosh, okay. Let's keep going. Let's keep going. I don't know what to do with myself right now. The whole reason I brought that up was because we are going to be classifying expressions based on certain rules that they follow. Some of them will follow the same rules but be more specific, so they'll be able to be classified by two things, but we'll use one of those terms more specifically, just like you could call a rectangle a parallelogram, but more specifically, it's a rectangle, even though it's both. Do you guys understand?
Yes.
So, ignore this question for a second. First, let's talk about polynomials. Yeah, let's talk about polynomials first. Actually, let's talk about monomials first. Monomials. I think this one is best described just by giving you a bunch of examples of monomials because they can vary in how they look, okay? Even though this is a very specific rule that has to follow, we're talking about, this is kind of like the squares of the polynomials because it follows a very specific rule. And examples are, we could do 7, we could do x, we could do 7x, we could do xy, we could do 7xy, we could do 7x to the 4th, y to the 3rd. These are all examples of monomials. They follow a certain rule. Yes?
One term.
One term. Very good. Now, it's weird because like, when I say one term, like that definitely looks like one term. But when I look at that, it doesn't look like one term, it looks like a lot of terms. What denotes a term though? Like, how can I call this one term if it's got a lot going on in it? Yeah?
Because like how they explained in the video, there's like 2 squares and everything, like 2 upward rectangles, and like the 7's in one box, and the numbers are in the other box.
Okay. Okay.
A 7 is a whole number while the points are on the exponent.
Yeah, well, we call this a coefficient. It's basically when you have a number or a constant that is attached to the variables. When I say attached, what operation am I talking about? Multiplication. So a monomial is one term, but technically you could call it a polynomial, even though that sounds really weird, because like poly, doesn't that mean many? But it's a very specific type of polynomial because it only has one term. Now, a term could be simply a constant, it could be simply a variable, it could be a product of a constant and a variable, it could be a product of a couple of variables, it could be a product of a constant and a couple of variables, it can be a product of a constant and a couple of variables that also have exponents. That's one term, we call it a monomial. Yeah.
A term has to have a coefficient and a variable.
It doesn't have to.
It said it does, but the x technically does have a number. It's
Oh, I see what you're
X with
saying.
the zero
It can have invisible.
Yeah.
Yeah.
It has to have a
Yeah, I'm actually gonna get to that in just a second when we talk about the degree of 0. Yeah.
Is the next one binomials?
I wasn't even gonna go to binomials just yet. So now that we talk about monomials, I wanna talk about the degree of each of these monomials. Now, I'm gonna leave this one last. You find the degree of a monomial simply by adding up the exponents in the monomial, okay? Adding up the exponents of the variables, I should say. So, just for kicks, I'm just gonna put my little invisible ones here. And when you add up the variable exponents, you get your degree. So this degree would be
First degree.
1. This degree would be
One.
1. This degree would be
Two.
Good. This degree would be
2.
And this degree would be
7.
very good. This degree is
0.
0. How do you know? From the videos?
Yes.
Oh, okay, good. Because 7 technically could be written as 7x to the 0 power. Because x to the 0 power is the same thing as writing 1. And 7 times 1 is 7. So these don't look like the same term, but they have the same value. So a constant technically has a degree of 0 because that's what its variable has. Kind of what you were saying before about those invisible variables, okay? All right, so they give you 2 charts here, and we are going to kind of break it down by their names based on the category that we're talking about. Because we're talking about 2 different categories now. We're talking about naming it based on its degree, which is what we were just finding out here, the number of the degree. And there are specific names for each of those numbers. And then we're also going to name the expressions based on how many terms each polynomial has. What are you copying down right now? Oh, okay. Just making sure it's the notes from today and not notes from yesterday. Okay. So let's talk about degrees first. They just listed a bunch of polynomials. Some of them have only 1 term, like these monomials. This is a monomial, this is a monomial. What else is a monomial? Yep, this one's a monomial, even though it's kind of crazy looking, right?
Yeah.
You can tell that it's a monomial because there's no addition or subtraction with another term. These polynomials have addition and subtraction with other terms.
Makes more sense.
So we name, they also have specific names based on how many terms they have, which we'll name down here. But first we're just gonna talk about the degrees. This, we already said that every constant has a degree of 0, and the name is a constant, it doesn't change. This 4x is a monomial with a degree of 1. We call it linear. Just like if we had a linear equation and the x was to the power of 1, then it's a linear equation. So that's why we call this monomial a linear monomial or a linear polynomial. This one, now here's the tricky part. When you have multiple terms, you don't add up all of the exponents. You just take the sum of the term with the highest exponents. So this has an exponent of 2, and this has an exponent of 1. The degree is based on the highest
So the 2
exponent term. The 2 takes over.
So say
So
if there's
it's
like a 2, 1, and a 4, the 4 would be the name.
Yep,
And then you just add up 3, 2, and 1.
you don't add them up.
Okay.
You just take the highest one. So let's look down here. Let's skip to this one. Actually, let's look at this one first. This is just 1 term. So we do have y to the first power here. And you are going to add the 2 plus 1 because it belongs to the same term. Does that make sense? So we would call that a degree of 3. Now here, we're not going to add up all of these exponents because they're separate terms in the polynomial. You look at each term and you say, well, this one has a total of a degree of 4. This one has a degree of 1. This one has a degree of 1. And this one has a degree of 0. Don't add them all up. Take the highest degree term. And that's how you name it.
Why is that one called quadratic? And then why is that one called cubic?
Oh,
And why is that other one called?
so these are all we did so far was just name what their degree is, and each degree has a special name. So this is like the rule that it follows, the degree, and then it has a special name based on the rule. Just like a quadrilateral with two pairs of parallel sides, we call it a parallelogram. So here, if it has a degree of 2, we call it quadratic. Even though quad, you think of quad as meaning 4, right? It actually, I looked it up one time. In Latin, I believe it means, oh, I know, because quad means square.
What?
Yeah, it means square. Hold on. Let me do this, or I may stay silent. I remember looking it up a long time ago. I'll look it up again. Why is it called quadratic? Comes from the Latin word quadratum, which it means square. Which is interesting.
Square.
And like that's how we get the word square, because it comes from the word quadratum. Anyway, back to this.
Oh.
Okay, so we call a polynomial that has a degree of 2, we call it quadratic. And we haven't done quadratic equations and quadratic functions yet, have we? We will. Probably the next topic, I think, is quadratic equations, where they will look like this. This is just an expression, but it'll have equal to something. This monomial has a degree of 3. We call it cubic, which makes a lot of sense, right? And then anytime you go past the 3rd degree, you just call them by the number. So 4th degree, 5th degree, 6th degree, 7th degree, 90th degree. So we only have special names for 0 through 3 degrees. Okay, so when we name a polynomial based on how many terms it has, if it's only one term, we call it a monomial. If it has 2 terms, we call it a binomial, bi meaning 2. If it has 3 terms, 1, 2, 3, it's called a trinomial, 3, like tricycle. If it has 4 terms, 1, 2, 3, 4, or more terms, doesn't have a special name. We just call it a polynomial.
So if it's so if it's like 4y plus 2, would that be 2? Big 2.
4y plus 2, that would be 2 terms, so that would be binomial.
So what if it has an exponent?
That's fine. It can have lots of different exponents, but that has nothing to do with how many terms are in it. For example, if I have the number like 6x squared y to the 7z to the 4th plus 2, still a binomial. 1 term, 1 term,
So like
2 terms, binomial.
So like a sign separates.
Yes, this sign or the addition subtraction signs, yeah, separate the terms. Okay, you guys got this?
Hold on. As fast as I can.
What if the linear one has a
The linear
has an
can,
exponent?
it wouldn't, then it wouldn't be linear.
What would it be?
It would be whatever the exponent tells it to be. So if the exponent is 2, it would be quadratic. If the exponent is 3, it would be cubic, so on and so forth.
So if the say it's like 15, it'd be the 15th degree.
Yeah, because past 3, we don't have special names for them. All right, let's name each of these based on its degree and number of terms. So I'm gonna make a little like kind of chart here. This one will be based on its degree. Now it's not the number of degree, it's the name based on its degree, and this one will be the name based on the number of terms. So what would A be based on its degree?
Linear.
How in the world would it be linear?
It's quadratic.
Oh, wait.
Oh.
Oh, I see it now.
No, it's quadratic.
Well, no, because there's the invisible one and then you add them together.
Oh, that's right.
Cubic? Jack? Not necessary, okay?
Okay.
I
Now,
read it wrong.
so it's, remember, we can add them up when it's all part of the same term. If those were separated by a plus sign or a minus sign, we could not add them up. We would just take the highest exponent. But these, since they're all together and they're buddy-buddy in the same term, we can add them up and call it cubic. Now, the number of terms, how many terms do you see in this polynomial? There's only one. Now you see two variables, there's only one term. So this polynomial is simply called a monomial. Now let's look at this polynomial. What is the degree of the polynomial and what do we call it based on that degree? Lex? Quadratic. It is, because this has an exponent of 1 and so does this has 1 and this has 1. The highest sum would be this, would be 2, so that would be quadratic.
So, the number of terms would be, just, like, 3?
3, it has a special name.
Oh, yeah, cubic, no,
Trinomial.
yeah,
Trinomial.
that's what I meant to say,
I'm reading slow.
So it's like easy, but it's confusing, right? Because it's like learning shapes all over again, which you guys probably should do. I know, I was waiting for the reaction. Hey, that's mean.
That's me.
I'm not trying to be mean. Just
Well,
kidding.
no, you know what it was, but we just didn't raise our hands.
Oh,
Miss, like,
yes.
the last time we actually had to define shapes was like fourth grade.
First grade.
Fine.
Fourth grade.
Yeah.
Fourth grade.
Why?
Well, you better get ready because you have geometry next year.
Oh, that's gonna suck.
Yay!
All right.
Hooray.
All right, so the next thing we're gonna learn about, and this is so easy. From here on, it's like so easy, guys, okay? By the way, your homework, 6.1 is due tomorrow. It's 12 questions because they're so easy. That's why I put so many, even though 12 isn't that many. My kids get 30 problems a night.
Yeah,
I know, right? I give you like,
Oh, yeah, that was.
no,
Give us like 10 at
just forget about that.
Good, because it doesn't make sense.
It does make sense. It's just you're having trouble understanding it.
I didn't understand it, then my dad
Okay.
explained it to me, and then I was like, oh.
Okay, so here's super easy, ready? Here's this crazy big polynomial. We don't even have a name for it, it has so many terms. We just call it a polynomial. It has 1, 2, 3, 4, 5 terms.
Poly means many.
Yes, so we just call it a polynomial and we don't try to get more specific than that. Now, the thing about a polynomial having so many terms is if I write that polynomial, I might write it differently than the way he writes it. And he might write it differently from the way he writes it. And we all might be writing it in a way that the value is totally correct. But if they're all in different orders, it's really hard to see when things are the same value if they're all written differently. Right?
That's why they put like A in different something.
You wrote them in standard form?
Or I wrote them in like a different form.
Oh, that's a good point. So it took longer to grade because they weren't written in standard form, right? Even though they were probably correct, right? Thank you for saying that. That's actually a really good example. Uriah was grading his own sheet before, and he just said that he wrote them in different order, so it took a longer time to grade it. So there's a standard way to write it so that every time somebody writes a polynomial, it's written the exact same way. And just like we have things like alphabetical order in libraries and files and things like that, when we write it in the correct order, in standard form, it's simply from the highest degree down to the lowest degree, okay? So if you look at the degrees of these terms, you'll notice that the highest is 4. So you write that one first.
Yay!
Then the second highest is 3. So you write that one next. And there's 2, and there's 1, and there's 0, the constant. Now, to be very careful, I highly recommend when you have to take a polynomial and write it in standard form, I highly recommend circling your term with its sign so that when you pull it to put it in a new order, you always put the right sign with it. So I'm gonna write that as a step. Step 1, circle terms with their signs. Step 2, put in order from greatest to least degree. Can you pick your feet up, please? Everybody get those down? Yeah.
Make it up.
You know we're supposed to have the ATP deal?
Oh, it's a good question. They didn't tell me.
Because normally it's either in second or seventh, but I don't think it's happening.
I really hope it doesn't happen. We have a lot to do, please. That's enough. Okay, so we know how to do this, right? Okay. It's okay. I just have to move on because I only have a few minutes left. If you pack up, you stay later. Yeah. Can you pick your feet up, please? Okay. Ready?
Yeah.
Okay, I'm not gonna do this with you guys. I'm gonna skip it because the next example requires us to use this rule anyway. So I'm actually gonna use the try it from the next example to teach both writing it in standard form and combining like terms. So we're gonna do two things, but we're gonna follow the exact same rules. Step 1, circle the terms with their signs. Now, just like we were putting step 2 when we were writing it in standard form, we were looking at the highest degree first to write that first. Since some of these terms can be combined, we want to combine them, but we want to start with the highest degrees so that we naturally will put it in order. Otherwise, you're going to combine, like this one already is in, like, has the highest degree first, and so does this one. It's a little annoying. But you'll have like homework questions where it doesn't give you the highest degree first. So if you don't think about that, you're gonna get an answer and then you're gonna have to rearrange it again. So skip that step by circling your terms with their signs. Then start with your highest term, which is these. Combine. What would that be?
4x.
3x.
3x squared